This video is going to go over the power equation, which can be found in the textbook on page 130. There are several practice problems that we'll review also in this video. Below on the screen you can see the derived equations using the power equation, which is a form of rate. We're doing the amount of work done at a certain amount of time. So it's going to be divided by the overall time. But then we can reconfigure our equation here to find work and then again for time. So let's look at the textbook example. So the textbook goes through on page 130 and solves this equation for you using this problem. It says, you do 900 joules of work in pushing a sofa. If it took 5 seconds to move the sofa, how much power did you use? Now the equation that we're going to use is going to be the one to find power. So we're going to use that equation where power is equal to the work divided by the time. Now, if we look in our problem, we know how much work we've done and the amount of time it took to do that work. Well, 900 joules worth of work was being done, which is a measure of energy, and the time it took was 5 seconds. So we can plug that into our equation. Power is equal to 900 joules of work divided by 5 seconds. Nine hundred divided by 5 is 180. And what we end up with is joules per second. And joules per second is a special unit that we know of called a watt. So the amount of work being done over time is 180 watts. So let's look at one of the sample problems. So number 1 says, in lifting a baby from a crib, 50 joules of work are done. How much power is needed if the baby is lifted for 2 seconds? So in this problem, we're going to have to solve for power. So we're going to use this equation, power equals work times over divided by time. So we plug in the values. 50 joules worth of work is being done divided by 2 seconds. 50 divided by 2 is 25, and we get joules per second. And that is better known as 25 watts. So 25 watts worth of energy per second is being done, or 25 watts overall. Let's take a look at number 2. If a runner's power is 130 watts as she runs, how much work is done by the runner in 10 minutes? All right, so this one, we know the power and we know the time, but we don't know is the amount of work. So we have to use the derived equation for work equals power times time. Now there's 2 parts we have to worry about here, because power uses seconds as the time unit. So the first thing we must do is convert the time. So 10 minutes is equal to, in 1 minute there are 60 seconds. So just take 10 times 60, and that gets us 600 seconds worth of time. That's 10 minutes. And now we plug that into our equation, where work is equal to power times time. So the power is 130 watts, and we multiply that into 600 seconds. Now, a watt is a joule per second, right? So the seconds will cancel out. What we end up with there is going to be joules, which is energy, and that's how we measure work. So we take 130 times 600. We can use the calculator to help us. 130 times 600, and we get 78,000 joules. And that should be the answer for a runner question here, 78,000 joules. All right, let's take a look at number 3. It says the power produced by an electric motor is 500 watts. How long will it take for the motor to do 10,000 joules of work? So we've got the power, 500 watts, and we've got the amount of work being done, 10,000 joules. What we don't know is how long it will take, which is a question of time. So we're going to use the time equation. We'll plug this into our algebraically derived equation here. So we need work, which is total 10,000 joules divided by 500 watts. Okay. Now, we're looking at the units. Watts is going to be joules per second, right? So we have joules in our numerator and joules in our denominator. Those will cancel out. And this is like saying 1 over s. So that gets pushed back up to the numerator. We end up with just our units in seconds, which is time. Um, 10,000 divided by 500, we know that pretty easily. That's going to be 20 seconds. All right? We can just go ahead and cancel out our zeros, and we can see it's 100 divided by 5, which is 20 seconds. And that is our answer. So for how much this electric motor can do, 10,000 joules worth of work, it's going to be 20 seconds. And for the last problem, it states that 1 horsepower is a unit of power equal to 745 watts. How much work can be done by a 150 horsepower engine in 10 seconds? This one's a little tricky because we do have to do another conversion. So we have a 150, my apologies, horsepower engine. And we need to convert that into what it would be. 1 horsepower is equal to how many watts? Since it's equal to 745 watts, we're going to take the amount of horsepower and multiply it by the unit of watts, 745. We plug that into our calculator. We take 150 horsepower times 745 watts, and we see that it's going to be 111,750. And that unit's going to be watts because I've set it up so that my horsepower is in denominator and then multiplied by something in numerator. That gets us just watts. So we've converted that. So that's going to be equal to the power. So now when we look at the equations, we're going to use the work. We know power, and we just need to know how much work is being done. So we're going to use the work equals power times time equation. So let's plug that into our equation now. So we got work is equal to the power is 111,750 watts, and we're going to multiply that by the amount of time, which was 10 seconds. So we're adding another 0 on essentially. So it's going to be a total of the amount of work done. It's going to be 1,117,500, and our units is going to be work times seconds, which is actually going to be, watts times seconds, my apologies, which would actually be a joule. And we can tell that because if we take our, what we have here for watts, and watts is really a joules per second, and that's going to be joules per second times seconds, right? So the joule per second times a second cancels out the seconds, and that's what you're left with is a joule. So that's our final answer. 1,117,500 joules.